This WiLLcast is with Tom Schaefer of Wells Vehicle Electronics. Becca, what'd you think?
He is such an interesting guy. I mean, they don't make them like that anymore.
For sure.
The way he's been at Wells, when did he say? Since
I think the mid-'80s.
83, 85, something crazy.
Yeah.
And he had a really interesting life before that.
Yeah, very much self-taught, learned on the job. He had a little bit of schooling, but for the most part, kind of figured things out as he went. And when we were doing the WiLLcast, one of the things I kept thinking about was like, man, this is exactly why we do the WiLLcast. It's as many people like this that we can get on and kind of capture their knowledge and their way of doing things, just so over time people can see what's capable and what you can learn, and the knowledge that generation has. It's just it's a great thing to get that on video.
The first time I met him was actually over the phone. I talked with him, trying to get him to partake in a panel I was putting together for YPF, which he did, which was amazing. That was a really great panel we had here at Will, talking about the future of manufacturing. And I remember being overwhelmed by how much experience he had. It was a random recommendation that someone at Wells had put in when we reached out for a contact, and he not only was a great fit for what I was looking for at the time, but he was above and beyond, and so much experience. He's held so many different roles at Wells, which is a really unique company in what they do and how they build their own automation equipment. I mean, he just has...
Yeah, he does it all.
We talked with him for an hour, and I don't think we even scratched the surface of his knowledge base.
Yeah. And he puts things in a historical context too, which I think is really cool, like talking about trends when he first got started, how it was a lot of the changes in automotive electronics were driven from government policy, and then getting into consumer electronics and how that was related to automotive electronics, and the offshoring that happened the last couple decades, and now the onshoring that's happening, and just to be able to see that kind of holistic view of the American economy over many decades is fascinating.
Did you feel like there's a lot of parallels? Or do you feel like there are a lot
with them and us? Or?
Yeah, well, just so much of I guess the auto industry and the lighting industry. And maybe I'm just having...
I think so. I think we work with the auto industry a little bit with some of the electric vehicle charging. They're exclusive. I shouldn't say exclusive. A very high percentage of their business is auto. They have multiple channels to market.
Right.
Similar to us, they have more of a retail channel. They have an indirect channel. I think with somebody like Wells, they kind of show us what is capable, what we're capable of with some of the manufacturing, the automation, and it's cool they're so open to having people through. Clearly we're not competitors, we're potential customers, we talked about that after the WiLLcast, but it shows us what's capable in our industry.
Well, and even I just felt like listening to him talk about some of the government regulations and the evolution of the industry and the way it changes, and there felt like there was a lot of similar characteristics when you talk about manufacturing, the aftermarket auto parts and LED lighting. I'm not sure, and maybe it's just a lot of the electrical components that could totally be it. But it felt really relevant.
Yeah, for sure. We're all working with the same ingredients at the end of the day. They have they have circuit boards, they have components on boards, they write software.
Many
entrees. Exactly. But yeah, it was great. I hope we can get more people like Tom. There's so much to learn from from Tom, and it'd be great to get a couple more people from Wells on a WiLLcast. But yeah, it was great to have him through.
Absolutely.
And this WiLLcast is brought to you by the Ledge Games. Becca, your favorite time of year?
My favorite time of the year, and it's officially September, so it's
this month.
It's Ledge Games time, Saturday, September 24th.
The last Saturday of the month?
Last Saturday of the month. Next year it's the 30th. Tyler already made fun of me. I had it wrong. No, Saturday, September 24th. Events kick off right around 8 a.m. There's usually a little bit of a opening ceremony of sorts, and then axes are flying, kegs are being tossed, hammers are being thrown. It's such a fun day. We are running out of spots to compete.
I better sign up.
Yep. I think we had one on hold for you. But visit ledgegames.com for more information. We're always looking for sponsors. We had a question about that the door's
Yeah.
always open for those.
Sponsors, volunteers, competitors, all the money made goes to support local builders and tradespeople and education and nonprofits and really anything related to kind of the core of Wisconsin manufacturing here in Fond du Lac.
Yep, I think it's close to $45,000 has been raised in over 6 years.
Nice.
It's entirely volunteer run. It's a 501c3. All the, dotting your I's, crossing your T's with that kind of stuff. But it's the best day. I'm highly
Cool.
biased.
Well, hopefully the rain stays away. And
Stop it.
we can handle a little bit of cold weather. It is Wisconsin.
Oh, it was really cold one year.
Rain could be a bummer, but either way,
Why would you
it'll
even
be
say
fun.
that? Don't say that.
It'll be dry.
It'll be
good. All right, well, enjoy this WiLLcast with Tom Schaefer from Wells Vehicle Electronics. So, Tom, what's your background? So, what did you study in school, and what's your career looked like?
Yeah, so school is interesting for me. I wouldn't recommend this. I have a high school education, and I went to what's called DeVry University
Okay.
for about a year and a half, and we just kind of ran out of money, and so I didn't get an associate's degree or a bachelor's degree, but I had 5 trimesters, and they gave you a diploma for that. And but I could program computers in 1983, so I got hired by Motorola's semiconductor research and development labs. Not probably because I knew enough about electronics, but I could program computers.
What did programming a computer look like in the early 80s?
Yeah, it was really
Punch cards?
Actually, I did punch cards in high school.
High school, okay.
My senior year in high school, I was a shop hound and auto shop, electronics shop, and instead of taking calculus, I took computer basics 1 and 2. And that has served me for most of my career, because from there you could pick up microprocessors. You could start, it just kind of introduced you to it. So, the command sets were really simple. You didn't have a big CRT in a lot of cases. You had essentially your calculator, single line, 20 characters to look at to type in commands.
Green and black, right?
And you wrote everything down on a piece of paper. And computer programming was really crazy. But you get to Motorola, and like first shift, that building was like parking at the Brewer game every day. There was like 10,000 people there. And you had to remember at the end of the day, I was in section D, row 5. You had to remember where your car was. But they had computers and equipment that could be hooked up to computers everywhere, and nothing was connected.
So was Motorola inventing the technology and the chips going into computing products, or were you guys also designing like a finished good product?
I think Motorola at the time was supplying microprocessors to Hewlett-Packard.
Okay.
So they kind of, Hewlett-Packard and Motorola had this thing together. So their labs were all full of Hewlett-Packard gear. And we were working in areas that you were kind of working on the first cell phone technology. Yep. The PhDs and master's degree guys that were in my department doing the work, they were working on all of that type of stuff. I had no clue what any of it was or how it
was.
worked.
Like the antenna side of it, or were they designing circuit boards or writing software? What was the cell phone technology?
So they were
component?
making the actual semiconductor that it was made out of. It's not even like semiconductors are typically silicon. This was a technology called gallium arsenide at the time. And so they were these little amplifiers and oscillators and mixers that were gonna, create the high frequency signal that you modulate the voice on top of, and it transmits across the air. And it was a really crazy environment. So my education was kind of learn
it's the best
computers,
education,
right? But couple of years of auto shop in high school. 3 years of electronics, electricity. So kind of when I got to DeVry, the first 3 trimesters of curriculum, I kind of knew from high school already. Yeah, maybe the 25% that they taught differently, I didn't know. But then the microprocessors and everything, I could jump right into it because everyone else was starting from zero, and I already had a year of computer in high school.
So that was kind of an inflection point in just electrical and electronics in general. Prior to that, I guess maybe a better question is what did automotive electronics look like 50s, 60s, 70s, and when did things truly start to switch from electrical to electronics in that business?
Sure. Well, 1975 is kind of a line in the sand year, if you will. So pre-1975, cars from 1900 to 1975 were, you essentially had a switch which was literally two pieces of metal that opened and closed, and they connected 12 volts to an ignition coil, and then they interrupted that. And when you interrupted the current through that ignition coil, it produced a brief 30,000 volt, spark that that would jump the spark gap. So it was literally a mechanical system. So there's a cam turning in circles, and at exactly the same time that the pistons at top dead center and needed to be fired, that little cam pushed the breaker points open, and it opened.
So it's just opening and closing a circuit.
That's it.
Based on a gear in the distributor.
That's it.
Yep.
And then in 1975, the federal government said all vehicles have to be electronic ignition. So GM did that. And at that point, in the U.S. market, I don't know my numbers, but let's just say like 75% of all sales or 65% of all sales were GM, Ford, and Chrysler at the time. The Hondas, Toyotas, Nissans were just really breaking into America in the early 70s. But so GM did their own thing. Ford and Chrysler did kind of different things, but they were big circuit boards for Ford and Chrysler. I mean, I'm talking big honking things. And GM did this little hybrid ceramic thick film, which we do at our plant in town here. But at that point, they're electronic switches. So 1975 was really a watershed event. And then the next watershed event, and I might not have my year perfect, but OBD, onboard diagnostics. So OBD1, I think, was 1996. And that you essentially have a computer, an ECU or an ECM in the car, and sensors hooked up to it. And it's kind of, telling the electronics what to do. And then OBD2, onboard diagnostics 2, came along, early 2000s. And that's now that little dongle underneath your firewall that, the technician plugs a cable into and gets all the information out. Yep. That's what turns on the service engine light that so many people hate because it results in a $500 bill for them. So that diagnostics, in order to do that, you had to have more and more sensors. Yep. So an engine went from essentially no sensors to suddenly you want a pressure sensor to tell, how to adjust fuel injection when you're at high altitude, low altitude, or during weather events or whatever. And then you have temperature sensors, and then you start having mass airflow sensors, and then they have mechanical valves, and OBD2 says, well, we have to prove that EGR mechanical valve is actually opening and closing. So then there's a position sensor on that, the throttle position sensor to tell the computer, hey, are you at idle? Are you at half throttle or full throttle? So then you have throttle position sensors. So OBD2 created all of these sensors.
How much of it do you think was a push from the government? I know there were mandates, mm-hmm. And something very similar has happened in the lighting industry over the last couple decades from the Department of Energy, really making a push to solid-state LED lighting from an energy management standpoint, and then adding controls technology and things like that. But in the auto world in the 70s, how much of it was mandated by the government versus pushed or lobbied from the automotive industry based on the technology trends they knew were happening? And was it based on safety, or where do you think the why do you think there was energy behind that push?
Sure. Well, I think the government is pushing, to get cleaner emissions. The cars were really dirty at that point in time. So, when you draw a line at 1975, let's say, some of those automakers might have said, well, hey, we'll get there on our own speed. And so we all need a push sometimes, right?
Sure.
And so, the government pushing there was probably a good thing. But then the natural competition between everyone whose system is better and produces more horsepower or better fuel mileage or lower emissions or whatever. So, then competition kind of kicks in there as well. And then, maybe somebody's doing it really well, but their costs are terrible and their vehicle's really expensive. So who does it economically? So it all kind of, government is part of it, and then natural competition is the other part of it.
So that's why all the cars from the early 70s didn't have any horsepower.
Yeah. That after the muscle cars died and all of the emissions came in the mid 70s, cars all of a sudden became dogs. I look at,
true.
Now you have a vehicle with 300 horsepower and you don't even think nothing of it.
Yeah.
But the 80s vehicles, it's like you had 140 horsepower.
And you can hardly smell the exhaust coming out of the exhaust pipe on a 300 horsepower car.
Yeah, right. I mean, they're really clean and, I don't even think they're close to getting to internal combustion engines to where they could go yet.
Yeah.
There's so many refinements that can be done.
Well, I just read that by 2035, California is going to be banning internal combustion vehicles.
They said that, and on the same day they said, hey,
you have to throttle the grid, right?
Yeah. Because they're in the middle of a heat wave right now. On the same day they said nobody can charge their cars tonight.
Yep.
And it's like, but you told us all to get electric cars. So, it's, the industry is going to have to figure out how to catch up with charging infrastructure.
Yeah.
But there's so many aspects to that because it also has to catch up with how much capacity do you have to build batteries?
Oh, yeah.
There's not enough capacity to build batteries. And then how much capacity is there to mine lithium?
Yep.
And a lot of the lithium is in South America, Argentina and Brazil, and a lot of it is in Australia and some in China. Not a lot in the U.S. So if you want to have energy independence, you're still going to have to go somewhere else in the world to get some of those materials.
Yep, for sure. So back in the early 80s, you got involved in electronics, you're involved in mechanics. I guess now you're at WiLL's here in Fond du Lac you're an engineering leadership role. So from the mid 80s till now, where else did you spend your career?
Sure. So I started at WiLL's in early 1985.
Oh wow!
I'm from Sheboygan, Wisconsin. Okay. So I'm a local boy here. So I found
That's
a job.
Awesome.
Found a job back home, which I was looking for, and Motorola was a great place, but Phoenix wasn't for me. So I have a big family, so getting back to home was important. So we did that. Started at WiLL's, and at WiLL's we were starting to make production lines with robots on already. So we probably had a production line to make that first generation GM thick film ignition module. And so we probably had 15 robots there. And there's like 4 of us in that little plant. Like that big complex right now was a little 16,000 square foot building, and we had no clue what we were doing.
Was that right down the street on Brook?
Well, no, that's where the headquarters was.
Okay.
But out where you toured in the industrial park here, that's a pretty big campus now.
Yes, for sure.
But originally it was a little pole barn.
Gotcha.
And we had, like I said, we bang those robots into things. In the beginning, you have to imagine, if you have somebody running this all week long or whatever, what types of events might happen. And, you didn't think of half of them. So somebody pushed buttons in a different sequence of events, or a part fell in a weird way when you tried to pick it up, and it, caused the robot arm to slam into something. or the electronics wasn't that reliable. A thunderstorm would come through, and half of your robots would need a new power supply. And so yeah, the early age was kind of the Wild West, trying to figure out robotics. But so we had a good mix of manual jobs and a good mix of automation in there already in 1985. So yeah, building that from scratch. So my function was, because I did computers and I knew electronics, I was our test engineer. So really, Wells had a handful of maybe 3 or 4 word processors, but most people still did correspondence with typewriters and things like that. So there was a couple of those word processors. So I brought in 3 engineering computers and a bunch of Hewlett-Packard and Tektronix test gear and put them on the end of assembly line. And when a part rolled off the end of the line, if you had to check whatever the 6 or 8 basic functions to make sure it worked, you had that. So programming all those, and man, there was no YouTube. You just beat your head against the desk till you figured sometimes relatively simple concepts. There was just nobody to go to ask for help. There wasn't even an industry colleague that you could go to. So figuring it all out was interesting. But so yeah, I did test engineering, and I was in that plant for 23 years, and started out as me doing test engineering, and eventually we had a group of 5 people, and then we built a reliability lab with thermal shock chambers and vibration tables and salt spray. So then I did my test engineering manager plus run the reliability lab. And then for some reason we needed somebody to take over shipping and receiving, which I had nothing to do with. Yeah. So I did shipping and receiving, and so yeah, just kind of
it's kind of the way it works, right?
Yeah, got involved. Wells has always been a wear a lot of hats kind of a place. Yep. So
I've never worked a place like that. No, never, ever.
Never.
We're similar for sure.
And so yeah, I did that, and then eventually our headquarters was close to you here in this 100-year-old brick building, and we had our operation was relatively small. Even by 2005, we probably had 60 hourly workers and maybe 20 salaried engineers, design engineers, and automation people. But our main plant was sales, administration, finance, all that. There's 250 people there. So I kind of come from this little building where we did whatever we wanted. And, if you wanted to bounce a basketball off a wall while you were thinking you did it, headquarters was a little stuffier than that, But so I took an engineering leadership role there, and definitely didn't know. I'm not a design engineer. I can't design things, but being an auto mechanic at the time, I know how things work on the cars. And I focused on specifications of how to test something on an engine, what SAE specification applies, what ISO specification applies, and how to use it to get reliability and performance. So then working with, as the design engineers are designing new products, how to make sure that they're organized and all pulling in the same direction, and then they have products that meet standards.
How frustrating can it be on the design engineering side to have to work within some of the constraints within the auto industry? Do you think it is limiting at times, or is it nice to have a requirements roadmap based on those constraints?
Yeah, so Wells kind of has 2 businesses as far as engineering goes. So we have what we would call an original equipment business. We call it WEP, Wells Engineered Products. And so they do OEM jobs for like Harley Davidson, Mercury Marine, Polaris, ag people like John Deere. Borg Warner's a big customer. They were originally Delco-Remy alternators, which became Remy, which became Borg-Warner. So making electronics for companies. There, it's a very traditional. Their engineers have a set of specifications that they want their alternator or whatever generator to do. They're working with you to get performance out of, maybe you're making the electronics that controls that rotating device. So that's a collaborative environment between the WiLL's design engineers and them to finish up the specification.
So when they come to you, what percentage of the design is done?
It's all over the map. Sometimes you're involved very, very early, and they want collaboration very early. And sometimes they know roughly what shape they want, and they know what they want it to do, but they don't know how to make it do that, and they're not sure. For instance, like you probably have in lighting, heat dissipation is everything in a lot of these devices, and they don't know if they're saying, well, our device used to need 50 amps and now we need 60 amps or 70 amps, and we don't want to make the package any bigger. Can you still dissipate all the heat in that package? So that's a real collaborative, work jointly with their teams. We have a lot of really cool software simulation packages at WiLL's, and people that know how to use them. So to simulate, whether it's FEA or CFD, magnetic analysis. We do a lot of magnetic analysis. So yeah, just working with them. So on that side, it's they're controlling it. On the aftermarket side, it's kind of the opposite, right? Because you have a part that's already on a vehicle, and you're just waiting for the warranty period to end, and then at some point there's going to be aftermarket sales for that. And so WiLL's, for most of its 120 years, we've concentrated in a lot of aftermarket replacement parts, maintenance for your vehicle. So you're constrained by the external geometries of that part. It has to be, if not identical, you can't have somebody hold it in their hand and say, well, you've got the heat sink in a different place, or it's a different shape. It has to fit on the engine the same way. And if it doesn't look almost exactly the same, the mechanic thinks they have the wrong part, and they'll take it back without even installing it. So the external constraints are very rigid. What you do inside to make your part do the same thing, you have a little more latitude there.
I hear a lot from engineering leaders how there's been a trend over the last, call it 20, 30 years, towards people being less hands-on. And you have engineers that are now highly specialized coming out of college. Now you have somebody that's designing a circuit that goes into a part. They maybe never have run a drill press, or they maybe don't have some of that experience.
Right.
What have you seen? You're obviously a very hands-on guy, learning, on the job experience or self-taught. How important is it for, from an engineering management standpoint, for, to find people that are hands-on, or try and kind of move the trends back in the direction of people having that hands-on mechanical experience?
Yeah, we find that we have to get them the hands-on ourselves. I had a former boss, a president, that was very animate, and he said, guys, you are not going to solve your problems sitting in your cubes here. You need to get out of your cubes and get out into the real world and touch things, smell things, feel things, see how they're made, understand the constraints that somebody would go to. So, get down to the machine shop and see how they're machining something. But even taking our people out to some of our vendors that make metal stampings or injection molded parts. We do a lot of injection molding ourselves. Getting them to see how those processes work. Nowadays, YouTube and videos you can do a lot on, but really actually being in the shop, it's still different. And,
for sure.
So getting people out and seeing as much of that really, I think, helps them professionally to understand their engineering a little better.
For sure. And right now I'm reading the Carl Schaefer book, Iron Fist. I don't know if you've heard of it or read it.
I know of the book. I have not
I did.
read
I
it.
found one on I think it was eBay or maybe Amazon had it, but About 100 pages in. It's really, really cool. And it's, Fond du Lac has a pretty rich automotive history. Obviously you guys are a large part of that, but, Schaefer was a NASCAR racer, and obviously you have Mercury Marine, right down the street from here. Yeah, exactly. You guys, a lot of you guys actually go back to sourcing or engineering a part for Henry Ford, correct? Or what was the kind of the early genesis of Wells?
Yeah, I repeat the story I'm told, and I'm not sure how much it's grown over the years or not. But
I'm sure it gets more exciting.
Sure. I'm told that somehow Henry Ford and this guy named Robert Wells, somehow, I don't know if they knew each other from college, but they knew each other and were friends.
Yeah.
And so Henry Ford in 1903 was going to start the first mass production automobile manufacturing, and he needed people to make different parts.
Yep.
And so we made, in the early days, ignition coils, and they're essentially wooden boxes, maybe 4 inches by 4 inches by 4 inches, full of copper and steel and oil.
I think I saw, I don't know if it was the original prototype, but an early one, and it's funny to see all the electrical enclosures in wooden boxes.
Yeah, right.
That's interesting.
Yeah, no, I even wondered just what was the craftsmanship to make those little dovetailed boxes. I mean, they were dovetailed really tightly together and things. But and I don't know at what point that became more of a aftermarket, because again, back then somebody bought a vehicle and they tried to keep it running for 30 or 40 years, and you actually still have a lot of that today. I mean, most of the peak period of parts that we sell are for cars 10 to 35 years old. And every time we try to stop making something that's for 50 and 60-year-old cars because the tooling is just all worn out, and it's like everyone is so upset that we're going to stop making that, But so at some point we kind of became a replacement part, maybe they thought there's a better upside in replacement parts than the cutthroat, supplying where somebody knows down to the 100th of a cent what everything's supposed to cost. Nah.
Yeah, I was going to ask you about that too. Just some of the the challenges, as much as you can get into, but some of the challenges and rewards of being an auto supplier. Things can be quite competitive in some cases, but I know you guys have a couple different channels of business. But what have been some of the biggest challenges and the biggest rewards of your career as an auto supplier?
Sure. So I mean, a lot of our what we call our aftermarket sales they're going to the major retailers. So if you go into any town and you think of fast food, right, you drive down and they're all in the same place. McDonald's, Culver's, Wendy's, whatever, those names are in the same place. If you drive down the main drag here in Fond du Lac, you'll see the 3 or 4 major auto parts stores right on the main drag. And, it's a very competitive market. They're all competing, to have the best quality parts at the best value, and they want you to walk into a store and have availability. So, I mean, if you think about the Walmartization, if you will, is that a word? Walmart
is now.
It is now, yeah.
Replace the kind of pharmacy and all of the different things that combine into that what that Walmart is. Over the years there were a lot of smaller auto parts shops, and one by one, the major players that were outstanding at doing it, they excel in their industries, and they've taken over a lot of market share in the US. So dealing with those guys as they grew, they just needed more parts for more stores. And then as they got their stores, they were like, yeah, but we're missing out on sales because we only have 5,000 SKUs in this little store. We need bigger stores and bigger stores with 8,000, 10,000. I don't even know what the count is in one of those stores. But so to supply them, they need diversity of parts, and they need availability, and they need value. And it can be a pretty cutthroat business trying to find how do we make the quality and value they need to be competitive, and and if we can win, they can win.
Yep.
But they wait for nobody. If you're not doing a good job, they will find somewhere. And we all in the 1990s and 2000s spent a lot of time going over to China and the Far East to get lower manufactured cost. And the recent last 5 years, the world is a different place.
It really
right?
is.
It's 2019, and there's some pretty good offshoring going on, or onshoring going on, and so that's kind of exciting to see the pendulum maybe start to swing in the other direction a little bit.
Yeah, and you and I sat on a panel here a few months ago, and here at Wisconsin Lighting Lab, and we talked a little bit about that. And I was really interested to hear your experience over a few decades, where there was domestic manufacturing, and then everything swung to offshoring to lowest bidder, and now as you said, the pendulum swinging back, and we really saw that start when a lot of the tariffs kicked in back in 2017, 2018. Sure. And that really disrupted the supply lines from China, and mostly China. And we started to do, we're a much smaller operation than you guys, but we started to do as much onshoring as possible back then. And then when COVID hit, it just lit a fire on that trend, and there's even been more onshoring. We were fortunate that we got out ahead of it a couple years, and especially with our mechanical parts, our castings, our fabricated parts, our extruded parts. Wisconsin has such a great supply base for mechanical parts like that, and we now almost all of our mechanical parts are sourced from Wisconsin. But I'm interested, just if you look at like the macro 30,000 foot view from the 70s and the 80s, when there's a lot of domestic manufacturing, what happened each decade? And then what does that pendulum actually look like now, and where do you guys see the next decade going?
Sure, and I have a lot of opinions, which I'm more than happy to share. But they're just one guy's opinion, based on my experiences and what I've seen. But I can say a little bit firsthand what I believe happened within Wells and or even with some of our direct suppliers, and I think it can be used as a generalization for maybe what's happened in places. So companies have to adapt to the changing marketplace, and we all say that, and we all want to do that, but saying it and actually doing it are two different things. And one of the things that I found, and I've been fortunate, I've spent a lot of time in China, and I would say fortunate, but going over to China for 3 weeks at a time, 2 times a year is really hard thing to do. But the cool thing is just being in so many different factories. And what's neat is most of those factories were only started maybe 3 years before you get in there. I mean, they're not 50-year-old factories, right? So we look at our own factory and we say, if we knew 20 years ago what we would be building today, our factory would be arranged completely differently. But our product mix was different then. And then you have empty floor space, and all of a sudden you need a new operation or machine. So now you put it wherever there's empty floor space, but from a flow standpoint, it doesn't make good sense. So first of all, it's really cool to go over and see things that were arranged to be efficient for their business right now.
Yeah, they more or less, they were able to see the wrong way of doing it.
Yeah.
And then, we could, start from scratch 3 years before you get there, and hopefully, and it's a collaborative process. I'm sure you came back with ideas as well, right?
Oh, sure. But one of the things that really struck me is when we looked at our business from a 1990 standpoint, each vehicle had very few SKUs, and a manufacturer used that same module or device on 5 model years in a row or 8 model years in a row. And they might have also used it on 3 different engine platforms. Now, every engine platform has their own set of modules and electronics. A lot of times they're very, very, very different. So what used to be you would build relatively few part numbers. I'll use the word SKU at times, stock keeping unit. But you'd have relatively few SKUs, but you'd make lots of them. Well, all of a sudden, fast forward 20 years, and now you have very many SKUs, and the number of pieces for each you have to build is very low. So we call that low volume, high mix. You have a high mix of products, but a low volume. But what we found is that happened, but the machinery, equipment, and processes we were using to build them, it was still the machines that were really made for high volume, low mix. And what really stood out to me after a number of years is I'm an electrical and computer guy, and people on the mechanical parts would always say, hey, Tom, stay in your lane, we got this end of the business. But as I got up into management and I'm responsible for the financial cost and profitability of our products, I'm going, well, I don't know what's wrong, but something's wrong because our part is, X percent, 50% more expensive than the other guys. And I look and they would have a really small injection mold machine, no bigger than this table, that maybe costs $25,000 to buy the whole machine. And to put a tool to make a plastic part on it might cost them $5,000. But we have a $300,000 injection molding machine that's as big as this whole area, and a tool costs $60,000, $70,000, but you're going to make 5,000 pieces a year for whatever, 20 years. Do the math. It's 100,000 pieces. That's almost $1 a piece for the life of the tool, just to pay for the one tool. But you need 3 injection molding tools and 4 stamping dies and assembly equipment and test equipment, and the math just isn't there.
And it's interesting. I don't know, were you part of the tour when we did that panel? And we got our 3D print room.
Yeah, right.
And we're very different industry, but our value prop is low, medium volume, high mix. And as we were growing over the last decade, and as we learned about tooling and the different mechanical processes and sheet metal versus extruded parts, injection molded parts, die cast, sand casting, and you start to realize how tooling for low volume, high mix also becomes an innovation constraint, because you feel compelled to pay for that tool,
right,
even if the original design decision wasn't a good one. So what we did is we said, okay, instead of tooling up for 5 components for this bollard light, it's going to cost $60,000-$70,000 in tooling. Let's look at 3D printing. And for us, it's made economic sense, and we can make 70,000 parts per year. But it's very exciting to think about for smaller companies over the next couple decades, as 3D printing, some of the digital manufacturing happens, how much innovation, creativity that's going to unlock, because you're not going to have these distorted financial incentives where it's like, hey, we paid for that $70,000 tool, we better put it to work. So it's interesting that you guys had that observation a while ago.
Sure, and 3D printing is clearly a game changer. For us being under hood, I mean, most of our parts got to survive to operate to 150 degrees C, 302 degrees Fahrenheit. So now the 3D printed materials you can get can withstand that.
Mm-hmm.
But they also have to have a certain cosmetic appearance, and they have to have fluid compatibility and different things. So for the most part, 3D printing is a little bit, we have, I love your 3D printing room, by the way, and we probably, I don't even know, we probably have 8 or 10 3D printers, probably maybe even double that size, the slightly larger ones. But then we have a really big, I don't know if you saw our big 3D printer. It's about
I don't think so.
The size of this table in our engineering room. I don't remember the work envelope on that thing. If I had a guess, is maybe, I don't know, 18 inches by 12 inches by 8. I mean, it's a big printing envelope. And it'll print down to 0.025 millimeters. I think the resolution, it's about 1,000th of an inch in accuracy and resolution in the layers. So it's an expensive printer, but we're knocking out parts on that thing all the time.
Yep.
And so we watch like a hawk, because I can't wait for the day when we can print, the automotive grade plastics and not have to buy injection mold tools.
So that right now we're feeling a compactor.
Yeah, plate compactor.
Nothing like a
It's an
construction
earthquake,
site.
man.
Yeah, it's like we got either an earthquake or they're putting a parking lot in.
Yeah. I thought you got like massage table here or something.
What it feels like. But yeah, that's what we're exploring right now is metal 3D printers and aluminum, and for us in the lighting industry, there's as a smaller company, there's monster companies out there taking care of the high volume product. For us, it's low to medium volume, high mix, aesthetics, and 3D printers play a really good role in that.
Yeah, and some of the metal printers, it's not just how expensive they are, because some of them are, 300,000, 500,000, even more. So I've seen a couple of shops that are 3D printing injection mold tools, and the really cool thing about that, and I'm talking about, big tools, 2 feet by 18 inches. But those plates, when you're making an injection mold tool, you have all these like water passages.
Yep.
And those are getting bored in with straight end mills and things like that. But they can make the craziest curved spline twisted water passages to control cooling, because when you 3D print,
it just happens right away.
It's just support material in there or whatever. So they can make a shape that you can't do with a CNC machine. So some of what they can do is way out there cool and pretty exciting. But yeah, for us to 3D print little back plates and stuff, just still not there.
Yep. Well, I was fortunate enough to tour your facility, a few weeks back. I hadn't been there, but it was really cool. And I'm curious if you kind of, as much as you can get into just kind of the anatomy of your kind of engineering organization and, what type of engineering positions you have. You talked about design engineers, automation engineers, manufacturing engineers, just kind of some of the different, components of the organization in engineering, and really where is a lot of the engineering spent on the production side of things?
Yeah, got it. Besides designing our own products, we design and build most of our own automation and equipment, and have all the way back. So there's kind of a design engineering group, if you will, who's doing what you would call new product development. Those tend to be mechanical engineers, maybe 75%, and maybe 25% electrical engineers. So they're designing the products, and they're working with what we would call CAD drafters or CAD designers. So they're all doing mechanical design, 3D SolidWorks.
So your drafting department is separate from the engineering
department? They all work together in the same department, and they tend to work in teams of 2 to 5 people working on a project.
Okay.
Somebody's overall project manager and lead and design lead. Somebody else is doing some of the plastic parts. Somebody else is doing some of the electrical parts. And then, there's design review meetings regularly, and just making sure everything's gonna come together. And then there's kind of a principal engineer that's overseeing it, and an engineering manager that's responsible for multiple pods of those teams. So that's kind of the design side. So think of 2-year mechanical design degrees that would come from in town here.
Yep.
Moraine Park Technical College, Fox Valley Technical College, Lakeshore Tech in Sheboygan, or any of the Milwaukee or Green Bay, or people come from all over here. So the technical schools do a pretty good job with those disciplines. The mechanical, electrical engineers, they're coming from MSOE or the UW system, or sometimes from somewhere else. The competition, as you know, for good engineering technical people is pretty stiff in Fond du Lac, Wisconsin. But then, so for the automation, we have the same types of people, but they're working on the robotics and the automation and the tooling plates for putting things together. So there's an automation team that's I don't know, let's call it 10. I'd give exact numbers. I'm just winging it here. And then next to that, there's a test engineering team. So at the end of every production line, there's automated testers that got to connect up to the parts and measure everything that's important on it. So they tend to be electronics engineers that are computer programmers as well. So that's another group of 6-8 plus people. And then there's manufacturing engineering is for machines that are in production and running every day. They're either making sure they're kind of partly responsible for maintenance, but in a low volume, high mix production environment, you're always putting new parts into production. Yep. So they're part of assisting with the new product launches and getting whatever new tooling is associated with that line in. So again, that's a mix of mostly mechanical 4-year and 2-year degree kind of people. They're programming PLCs and working with sensors and pneumatic valves, light hydraulics sometimes. That's kind of the mix of the engineering disciplines.
What does a production line look like? You said there's mostly they're mixed use, kind of the low to medium volume, and then you guys will turn over a line. But what's the typical mechanical packaging size of a part? What is all happening on the line to go from raw material or component to a subassembly?
Sure. So in Fond du Lac here, most of our parts are pretty electronics based. Mm-hmm. So the front end of it will be an electronic circuit board. So that'll either be the FR4 surface mount circuit boards, and we have surface mount lines, if I had to guess 5 or 6 big surface mount lines where you're screen printing solder paste, high-speed placers for resistors, capacitors, diodes, transistors, microprocessors, power devices, and then reflow ovens and end-of-line testers. So you're making the circuit board first. The other type of circuit board we do is hybrid thick film. So that's a piece of glass ceramic that's maybe 25 thousandths thick, say a 0.5 millimeter in thickness, and but again, it's surface mount. But ceramic is much better with power dissipation, and you can get a lot more circuitry in a lot smaller place. So a lot of automotive parts need ceramic thick film substrates. So there you're printing on resistors and conductors. There we're printing them right and firing them right in our facilities. So those circuit boards then flow out to an assembly line, and there you're surrounding them with maybe you're gluing or attaching that circuit board onto a heat sink or a metal backplate or some structure that's part of the final assembly. You're putting usually a injection molded plastic housing around it, and then you're making connections from, the outside package always has whatever, a 8-pin connector and a 2-pin connector for different wire harnesses to connect up to it. So you got to get from those connector points on your outer package down to your circuit board. So you're doing interconnects with welding, wire bonding, different interconnects. In a few cases, hand soldering of leads that go through a circuit board, but in most cases, automated welds and interconnects.
Yeah, I've seen a lot of pick and place contract manufacturers. A lot of our LED boards or our embedded controllers, are made by pick and place CMs. But I've never seen an operation where you guys are following a lot of the same automation principles, but taking multiple components into a subassembly, like that.
Yeah.
What's the largest footprint part, or I guess subassembly or product that you make?
Yeah, I mean, think of, your iPhone times 3 or your iPhone times 4.
So it's fairly large.
Yeah.
Yeah.
Yeah, we make fairly large voltage regulators that go on, say, new Harley Davidsons, and those things are pretty big clusters with a big aluminum fin heatsink, and they dissipate a lot of power, and very cool technology in there. You think you're just turning AC voltage into DC voltage, but there's a lot of requirements on one of those bikes to make sure that everything works perfectly and you can control all your lighting and your heaters and everything you need to control in there, and not pull too much power off of the engine and keep the battery charged correctly.
And are you responsible for manufacturing as well? Or is it the design engineering, automation engineering, and manufacturing engineering? Is it the operations, manufacturing operations, is that a separate department?
It is. Over the years, I've been in charge of it for chunks of time, 5, 7, 8 years. I would say for the last 6 or 7 years, our vice president of operations is in charge of the manufacturing operations and all the manufacturing plants. But the lines between us all get really blurry and fuzzy, and there's areas where maybe I have a lot more input into what types of machines and processes we put in some areas. And then there's a lot of areas where I have basically zero input, and that's somebody else's. Maybe that's just they have more core expertise in that area than I do. So I mean, it's we all have good partnerships, and nobody's really, overly, there's no turf wars like, hey, stay out of my playground. We're all very collaborative that way.
Well, one of the things I kind of want to end on is just electric vehicles.
Yeah.
And your thoughts on that. You've certainly seen a lot of changes in the auto industry over the last last few decades. Where is it going? What are some of the challenges? Is WiLL starting to think about what that looks like from a company standpoint? I'm just interested in your thoughts on the topic.
Yeah, I mean, WiLL's a little bit. I mean, we tend to be a little bit more backwards looking because in replacement parts we're looking backwards 5 to 10 mile years. But I can tell you, our parent company is very, when internal combustion engines die, a big chunk of their business goes away, and they want to be a viable business forever. So they're very in tune with, when that'll happen, and there's a lot of thought by them going into what types of businesses that they want to get into, and what's a good fit for them. For us, just looking at it, I mean, me knowing automobiles, I mean, we touched a little bit before on infrastructure. A lot of infrastructure's got to get built. When you think about it, you pull into a gas station with a Ford F-150 with a 20-some gallon tank, and in 3 minutes you can put 500 miles of charge into that, and you drive away. And that gas station might have 16 or 24 pumps and be servicing 16 to 20 customers, with a turnover at each pump of once every 4 minutes or once every 5 minutes. When even if they have a quantum leap in charging capabilities, boy, I don't know what the count is in gas pumps just in Fond du Lac, Wisconsin, but it's got to be in the hundreds and hundreds. And how do you get hundreds and hundreds of charging stations? And by the way, if there's an event that can put 500 miles of electricity into a vehicle in 3 minutes, I want to be standing a couple hundred feet away from that transaction.
That's true.
And
That's true.
I don't want to leave any valuables in my vehicle. I mean, you would think they'll get that safe, although I've seen a couple of the videos of a fire that starts at a charging station. It's pretty scary. But so, a lot to be figured out there yet. I just believe that the internal combustion engine, I mean, I've read a lot of articles by all of the big companies that do this type of work. And, some of the really ambitious projections are still saying model year 2040 in the U.S., new vehicle sales will still be, primarily internal combustion engine. It might be a hybrid, but there's still an internal combustion engine on that vehicle. I just wonder if 20 or 30 years from now, is somebody going to figure out a fuel cell or something different than lithium-ion battery? I mean, if a lithium-ion battery is so great, why aren't more of our lawnmowers that? Because when you think about it, you use it for an hour and you put it in your garage for 5 days. Yeah. And that's like a cordless drill, right? It's the holy grail. You're not running it, for a 5-hour trip, somewhere. It's just you use it for an hour and you put it away. But yet, and maybe it's a cost thing yet, but why are so many of our lawnmowers still gas,
For sure.
So it's going to happen, but I think it
seems overly ambitious.
It's ambitious.
We actually we do work a little bit in the charging space, and there's definitely a scramble to try and figure out how to do it. And there's I don't think there's really a unified way of unified approach at this point. Even we're right next to Sadov, the recycling company, and I was talking to them yesterday, and just the things that have been built slowly over decades on how to recycle all the materials inside of a vehicle, and all of the the dissimilar metals that are involved with electric vehicles versus your kind of classic vehicles. There's just so many things that have to be worked out. It'll be interesting to see what happens.
Yeah, right. And but there's a long time for the market to sort itself out, and we'll just have to wait. See, I can say that Wells is really good at power electronics. So if we need DC to DC converters or AC to DC converters, I mean, every couple of years there's a new gizmo on a vehicle, and we just figure out how to make them. And normally it's especially when it already exists. You say reverse engineering is easy, but reverse engineering something cost effectively and doing it on equipment you already own, or to make it use of existing resources is a pretty big challenge, but that's something I think we would be really good at. And so as those
there's going to be opportunities.
Devices get into vehicles, there's opportunities. I mean, when we described the 1975 event and the OBD2 events, Wells just started making different kinds of sensors, and you just learn those technologies and leverage your core competency that your company, you guys have years of experience in things. Well, you layer this new technology into competencies you already have, and a lot of times it's a really good marriage.
Well, Tom, anything else you wanna touch on? I know you guys you seem like you're getting more and more involved here in Fond du Lac, and the tours, and it's all great to see you give back and kind of share that knowledge base.
Yeah, Wells is, our previous ownership groups, I mean, I've worked with them all over the years in our management, but we're much more local based than we used to. Now, when I say local, let's say that we all live within 30 miles of here, but we're not flying in from, 1,000 miles away. And so we've always felt like we were this company, like people in town would even say, Wells, who are they? And like, we're one of the oldest companies in town, and far older than Mercury Marine, but we've been way too low profile. So all of us really enjoy getting out, whether it's at Walleye Weekend or just at all of the different
the
events,
Envision events,
and the Envision events, and just participating in the community, and Fond du Lac and the Fox Valley in general is just a great place, and we just love being part of it.
Well, thanks for all you guys do, bringing people through. I've learned a lot, and it's nice to kind of turn the various factories and operations inside out and learn from each other. And yeah, thanks for coming on.
Yeah, you bet. Enjoy it a lot.
Let's talk again soon.
Sounds great.
All right, man.
Thank you.
Thank you very much.
Thank you.
Yep.